talk about how we can minimize the cost. So the cost for producing X Bluetooth speakers is given by the function C of X equals 0.1 X minus 50 quantity squared plus $1,500. Find the vertex of this function. So the vertex of this function, if we were to see that this is in the form A times X minus, whoops, why is that not? Oh, I hate it when it does that. A times X minus H plus K, oops, squared. So this is our format that we're in. So remember, the vertex is HK. So the vertex of this function is 50, 1,500. That's it. I'm done. I don't have to figure anything out. I just look at it and go, that's the vertex. Is the vertex a maximum or minimum? Well, this is positive. So the vertex, so this is a happy graph. So the vertex is going to be a minimum. Interpret the vertex in the context of this application. Well, it'll be the units that minimize cost. And that's 50 units minimize cost. And the minimum cost is $1,500. That's the lowest our costs can be. So let's graph this function in a window that includes a vertex. So now we want to look at this using our calculator. And again, like I said, now that we have a little more information about how quadratic functions work, it's a little bit easier. So we have 0.1, and then we have an open parenthesis, X minus 50, close parenthesis, there's my squared, just keep it there, plus 1,500. So I'm going to go to my window, and there's the vertex of the function. So I'm going to go make sure that I cover the vertex, but I also like to make sure that I cover a little farther than that. I want to cover at least twice what the vertex is. So let's go 150. And I'm going to make my X scale 10. That'll make it good. My Y min, well, I can't sell less than 0, so I don't really need that. I need to go at least 1,500, but at most 1,500, because remember, this is a happy graph. So the 1,500 is going to be the smallest it's going to be. So I need to go quite a bit larger than 1,500. So let's do 5,000. And then here we'll make the scale 500. I think that'll look a little better. So let's graph it. I can see the vertex. The vertex is right here. So I can actually see the vertex on this. So what I ended up doing was 0 to 150. That was my X. And my Y was 0 to 5,000. So I got my vertex in there, and it did just fine. That would be perfectly fine. I could make it a little bit larger. There's a lot of different things I could do. There's absolutely no reason to go below 0 on either one, because neither cost nor units can go below 0 anyway. So this is the minimum cost that we can have, is 50 units. That lowers our costs the most. So it says, describe what happens to the function between x equals 0 and the x coordinate of the vertex. So between x equals 0 and our x coordinate, so let's go and let's just grab our vertex real quick. Number 3. So left bound, see, I know where the vertex is. So I know to go just below 50. And that's pretty good. Now, one of the mistakes that I saw on the test is people weren't making this bound small enough, and it was giving answers that were off. Enter right bound. I want as close to 50 as I can. And my guess, I can't guess in there, so let's make that. So we notice that we have x equals 50 and y equals, so we know that. So there's our minimum. So I wanted just to put this x here. So what is happening to the function between 0 right here and my minimum right here? And what's happening is that the function is decreasing. And what that means in the context of the problem is that costs are, like total costs are decreasing. Between 1 or 0 rather and 50 units produced. So